Hello again. I will now introduce the process for creating electrospin fibers, and I will also demonstrate how these fibers can be used in a capacitor to create a capacitor with a much higher capacity and much faster time constant. In this diagram, you can see the setup for producing a electrospin fiber material, where you have a cylinder which is positively charged and an extrusion nozzle that is negatively charged. Under normal circumstances, you'll see that without a presence of electric field, the droplet forms at the end of the nozzle because of surface tension forces. This surface tension limits the droplet size, so a finite thickness of filaments can only be produced without the presence of electric field. By introducing an electric field, the surface tension force is broken and overwhelmed such that the nozzle can now extrude a filament which is much thinner than the one above where the surface tension limited the droplet size. So it is by this process that a filament of very thin size, nanometers across, is produced, because the electric fields allow the surface tension to be broken and a thinner filament to be produced. Now we'll discuss the 4 steps necessary to produce a capacitor utilizing the electrospin fiber material and multi-walled carbon nanotubes. Creating a capacitor that uses electrospin fiber multi-walled carbon nanotubes can be done in 4 main steps. The first step is to acquire a pure sample of carbon nanotubes. As most carbon-containing compounds are burned, the carbon skeletons of the organic molecules are left behind as bits of broken chains of carbon molecules. A sample of carbon soot can be filtered several times by a metal or paper screen to remove the larger, longer carbon tubes. Once the nanotubes are isolated, they would be mixed in a substrate such as polymethyl methacrylate and extruded into a filament using electrospin method, as you can see in the first 2 diagrams. In order to increase efficiency, the electrodes and a dielectric material can also be produced on the same assembly chain, as shown in Figure 3, and layered into a cylindrical roll for capacitor use immediately after extrusion. A capacitor of this type could have a very high capacitance due to the overwhelming increase in surface area compared with the traditional foil capacitors, which contain no cylindrical fibers and only a planar surface. Also, the time constants for a capacitor of this type would be very quick due to the high electron mobility in the fiber mesh. The presence of the multi-walled carbon nanotubes almost produces a superhighway for the electrons to flow down with little resistance. The capacitor could also be further improved by trying different kinds of dielectric material and filament substrate to find which combination of materials provides the best time constant or capacity.